Hi there. Today we are going to talk about the wireless networks. But before that, we would like to thank to the team of the wireless networking in the developing world, second edition. I would like to suggest it to everyone because it has a lot of good stuff relating to networks, wireless networks. So it's really easy to understand, and you can get the idea what are you looking for. So let's get to the main topic, a wireless network. So what is a wireless network? Before going into the main topic, we would like to discuss about why do we need wireless networks. So in the previous some decades, the population is growing really fast, and you cannot manage cables and such things. I mean, it's really difficult to handle those things. So due to growing world and population, wireless networks are really helpful. So you can use radio frequency, and you can connect two devices in a wireless network via radio frequencies. So what are radio frequencies? What is electromagnetic spectrum? And what are bands? All these things we are going to discuss in the videos. So radio waves are the type of electromagnetic radiation with the longest wavelength in the electromagnetic spectrum. So radio waves are just a part of the electromagnetic spectrum, or it's a band in the electromagnetic spectrum. So what is electromagnetic spectrum? The electromagnetic spectrum is the range of frequencies of electromagnetic radiations and their respective wavelengths and photon energies. So based on the energy, frequencies and amplitude, they carry different energy in terms of quantity. Okay, so we have discussed computer networks. Well, it can simply be answered as the wireless networks. A wireless network of computers or communication devices is a network which can be connected and communicated wirelessly regardless of wires. Or we can also say that a wireless network refers to a computer network that makes use of radio frequencies connections between nodes in the network. Wireless networks are a popular solution for homes, businesses, and telecommunication networks. So it also gives us the opportunity to roam around and move around in your room, apartment, or open areas, because as long as you are in the coverage area of the signals, you can have the internet access. So wireless networks keeps the devices connected while still allowing us the freedom to move around. Well, this was a short introduction to the wireless networks. The question is, how does it work? To find the answer, we'll have to dive into some basics of wireless networking. So you can see here I have a portion of electromagnetic spectrum. This is called the radio band. These are the radio frequencies, and there are various applications of radio frequencies, like from 3 kilohertz to 30 kilohertz. We can use it for maritime navigation signals. From 30 to 300 kilohertz we can use it for navigation aids, and from 300 to 300 gigahertz we can use it for short radio waves, FM radios, AM radios, UHF and UHF TV signals, satellite and microwave telecommunications, and so on, like radio astronomy, radar landing system. Now, before we go to the topic, the wireless networks, I would like to discuss some of the descriptors of the wave, because wave is the one on which the wireless networks depend. So what is wave? Wave is the main ingredient of the wireless networks, and we have some of the descriptors of the wave. Descriptors are something that are associated with waves on the basis of which we can distinguish waves, frequencies, and amplitude and their characteristics. So a wave is a disturbance in a medium that carries energy without a net movement of particles. It may take the form of elastic deformation, a variation of pressure, electric or magnetic intensity. Let me show you what does it mean by without a net movement of particles. So you can say that if you, as you can see the wave in the figure, so let's say if there is a particle over here, so this particle will not move along the wave, but rather it will vibrate or it will oscillate around a fixed axis, like it will go up and it will go down about fixed points. So there are some of the descriptors of the wave. Now we are going to discuss this. The first is the wavelength, the second frequency, amplitude, velocity, and displacement. So we are going to discuss them one by one in a very short but very clear. Now, so what is a wavelength? A wavelength is the distance between two successive identical parts of the wave. What does it mean? It means that, let's suppose we have this wave, as you can see the wave. So a wavelength is the distance between two successive identical parts of the wave. You can see that here we have one and here we have two identical points. Likewise, if you can see below, we have one and we have two. So the distance between these two identical points or particles is called the wavelength of a wave. It is denoted by a Greek word lambda. Now the frequency, we can define the frequency as the frequency of a wave is the number of repetitions per second, which is calculated in hertz, or you can say that the repetition of oscillations in the given time period is called the frequency of a wave. Like you can see over here, so this is one complete oscillation. So the number of these oscillations through a fixed point, like this is a fixed point, or you can say, let me show you clear, you can say that if, let's say, if this is a fixed point, right? So the number of these repetitions or oscillations through a fixed point in a given time period or in a given unit of time is called the frequency of a wave. Like in this case, we have here one oscillation and here we have two oscillations. If these two oscillations are passing through a fixed point, here in this case this is the fixed point, in a given unit of time, let's say we have 2 seconds, and these two oscillation passes through that point in 2 seconds, then we can say we have a wave or frequency of 2 hertz. It is denoted by capital H and Z, right? Okay, now what is amplitude? An amplitude of a wave is the maximum displacement from the neutral position. This represents the energy of the wave. It means that greater the amplitude of the wave, greater the energy it carries. And what does it mean? Let's suppose in the given diagram we have this wave and it has an amplitude, this one. We have this one amplitude. So this is the maximum displacement from the neutral position. Let's say we have this line, this one. So it is the neutral position, and the maximum distance of a wave from this position to the top is called the amplitude. Now, if you have a larger amplitude of a wave, like, so we have amplitude like this, or like this, or like this, or like this. So you can say that these amplitudes carry high energies. So greater the amplitude, the greater the energy it will carry. Now the fourth descriptor of the wave is velocity. So what is velocity? The velocity of a wave can be defined as the speed at which a specific part of the wave passes a point. It's called the velocity of the wave. Let's say we have a point over here on the line, and let's say if we have some particles or the wave over here, like this is the wave, and this wave is passing through this point in a specific time. So the speed of the wave through this specific point in the medium, it will be called the velocity of the wave. Now the fifth one is displacement. So what is the displacement? Displacement in a wave is the position of a particular point in the medium as it moves, as the wave passes. Like we can say that we have a particle over here. You can write we have a particle over here, and when the wave is passing through that particle over here or over here, so the maximum distance it covers from here to here, or from here to here, and so on, it will be called the displacement, or displacement of particular point on the wave. Now, as we are somehow we have become somehow familiar with the waves, there are certain types of waves. Depending, we can distinguish these waves from each other in terms of their propagation and their characteristics. So the first type of the wave is there is the transverse waves. So what are transverse waves? Transverse waves are those in whose medium move at right angle to the direction of the wave. Like we can say that here is a wave. I can write here we have a wave. Let's suppose this is our graph, y-axis and x-axis, and we have a wave over here like this. So in transverse waves, the medium, the particles in the medium do not move along the wave. Like if you can see that the wave is moving in the x direction, x-axis, and the particle will move like up and down, and this particle will move like in the y-axis. So it does not move with the propagation of the wave. So such type of waves are called the transverse waves. Also, we have the there we have one term, the crest and the waves. Crest and the trough. We have this graph, and here we have a wave like this. So the highest points are the highest amplitude above the x-axis. These are called the troughs. These are called the crests, and the below are called the trough of the wave. Examples are the water waves, light waves, S or shear waves of the earthquake waves. Like when you put something in the water, the wave will go along on the surface of the water, but when you put something on about those waves, it will not move the object forward, but instead the object will move up and down on the wave as the wave passes through that particular point. Now similarly, the light wave also propagate in the same manners, and also the S wave, which are the secondary wave of earthquake. You can see that the light waves is coming from the source to the receiver. You can see that it is a source generating like in the given example, you can see that here is a source of the wave which is producing light wave. So the light wave propagates along the x-axis to the receiver, and we have trough over here and crests over here. So the crests are also, we can say that, or the trough, we can say that these are the amplitude of the wave. Similarly, there is another type of waves that are called the longitudinal waves. So a longitudinal wave can be defined as a longitudinal wave has the movement of particles in the medium in the same dimension as the direction of movement of wave. What does it mean? It means that, let's suppose we have a wave propagating from the source. Let's say if this is a source and it is producing or generating the longitudinal waves. So the longitudinal waves will be like in the form of compression and the rarefaction, like this and like this. So the part of the wave where the particles will be enclosed, or where the particles are close together, will be the compression part, and the particles of the wave where they have larger distance as compared to the compression one, this will be called the rarefaction. So we have a couple of examples of longitudinal waves in which you can see the first example is sound waves, and the second example is P-type waves. The P-type waves are actually the primary waves created by earthquake. So I'm gonna give example like okay, before going to the example, keep it in mind there are two parts of longitudinal waves. The first one is compression and the second one is rarefaction. So we will see in the next example. Here is the sound source I was talking about. Here is an example. So if you can see, here we have some loudspeaker or sound system or music system. It is generating longitudinal waves. The longitudinal waves propagate from the source to the receiver in the form of compression and rarefaction. You can see that in some parts of the waves we have closed particles like these one. So these particles are these parts of the wave. This is called the compression part, and where the particles of the wave are separated or they have the long distance as compared to the compressed one. This is called the expansion or the rarefaction part of the longitudinal wave. As we have discussed some of the descriptors of the wave and different types of the wave, now we are going to discuss about some other types of waves. The type of the waves we discussed earlier was those were like mechanical waves, and now we are going to talk about the non-mechanical waves, which are the electromagnetic waves. So these waves are the disturbance that does not need any object or medium for propagation and can easily travel through a vacuum. So if you can observe, or if you have seen the satellite communications, it's like they don't need any medium or object for the wave propagation. Like we have the earth stations and we have the satellites on like 36,000 kilometers above the earth. We can communicate with each other, though we know the space is like a vacuum. It doesn't have any medium, it doesn't have any object for the waves to travel. So electromagnetic waves are the one which can travel without the need of medium or object. So they produce due to various magnetic and electric fields. If you can see the figure over here, you can see, let's suppose we have an electric wire, or this is let's say the simplest form of antenna. So when in the wire the current goes up and then goes down with specific frequency, then it will produce a magnetic field around it. Let's suppose we have a current flowing upside in the wire. It will produce the electric field around the wire. Similarly, when the electric field is produced, it will induce an electric current in the same manner. But these fields will be proportional to each other. Let's say if the current flows in this direction, the field will be created, the magnetic field will be created in this direction, and the electric field will be in this direction. Similarly, when the current changes its direction, the electric field will be like in this direction, or the electric field will be like in this direction, and the magnetic field will be like in this direction. So these changes in the electric and magnetic field occur as we change the direction in the wire, and since they are able to propagate in the free space. Now we have three figures over here. You can see the electromagnetic spectrum, the radio frequencies, and we have a very short range of visible light over here. So let's say we have a complete electromagnetic spectrum. Let's say this is our figure number 1. So it has this range has a complete range of frequencies. Now you can see that the red one, like this one, this portion, it has a range of frequencies, and that range of frequencies has another sub-range of frequencies. We call those ranges the bands in the electromagnetic spectrum, or the sub-bands. Like we have the sub-bands. This is our radio frequency. Let's suppose this is our radio frequency band. Now in radio frequency band we have some other sub-bands over here. We can use these bands for different purposes and for different applications. So you can see we have radio frequency over here. We have a very short visible light frequency range over here, and some other some other frequencies range over here. So some of these frequencies, these are very are extremely and tremendously high frequencies. These frequencies can be used in different medical treatments, chemical reactions, and those have a lot of advantages and disadvantages. So we will, once we get into the topic deeper, we will discuss about that. Now, moving on to the next slide. Here in the following table you can see the electromagnetic waves range, which goes from like below 3 Hz and goes all the way up to 3 terahertz. This is the 3 terahertz. Okay, so this is from 3 terahertz, 300 gigahertz to 3 terahertz, and you can see the ITU designation. Here is the ITU designation, International Telecommunication Union. These have and this is the frequency range, for 300 to 30 to 300 hertz frequency. It will have a wavelength of 10 power 4 to 10 power 3 kilometers. So the 3 kilometers is, if you remember, we have discussed about the wavelength. So let's suppose this is a wavelength, this is a wave, and we can say that these two are two identical successive points. So the distance between these 2 points, in this case, like in 30 to 300 hertz, let's suppose if I take the 30 hertz, this distance will be like 10 power 4 kilometers. So it's a huge distance, and the range over here, it will be like 1 millimeter to 0.1 millimeter, and we can name these frequency as the extremely low frequency, super low frequency, ultra low frequency, and the list goes all the way up to tremendously high frequencies, which comes in the band or which comes in the frequency like 3 terahertz. We have also the IEEE bands over here. These are the IEEE bands which are managed by IEEE regulations. So you can see also the C band, the KU band over here, and these are the C and the KU band, which are used in the satellite communication. Like the C band, if you have seen white LNBF on your dish antenna, it uses this band, the C band, and also the KU band. Similarly, we have a different radiation frequency range. We can name those frequencies, we can give a different name, like these the gamma rays, the X-rays, the ultraviolet rays, the visible light. The visible light range, this is the visible light, and the frequency range will go from like 4 to 7.5 into 10 raised to power 14. Keep watching our videos, subscribe our channel, do like, and also comment in the comment section if you have any questions. Thank you so much.